Hello there. In video EB26, I carried out a hardware review and teardown of Radtel's new RT-950 Pro. Now in this video, I'm going to run a rudimentary RF performance test on it, covering three areas: RF power output, harmonic emissions, and sensitivity. And a big thank you to Radtel for collaborating with the channel to offer you a 5% discount code. So if you use this code ElectroBananas on checkout at the Radtel site, regardless of what you buy from Radtel, you will receive a 5% discount. Now before we get into it, I just want to give a quick disclaimer. First of all, I'm only using hobby grade test equipment, so the results should be taken as indicative as best. Secondly, I'm not suggesting whether this radio is legal to use or not. It's your responsibility to check whether the use of the equipment is permitted under your license and the regulations of your country. And finally, the software version loaded onto this radio is version 0.18 and the hardware is at version 1.0. So make sure you check Radtel's website to see if there's a later version available, because any issues highlighted during these tests may have already been addressed and updated in firmware or hardware when you watch this video. Now, in case you want to repeat these tests yourself or do them in the same way that I've done them, let me introduce the equipment. So this is a nano vector network analyzer, or VNA. This is a H4 series, and I use this for checking the integrity of the attenuator or load that I'm using, and other filters and things like that, and also SWR of antennas. This thing here is a DC block. It's basically like an inline capacitor and prevents DC going into the inputs of the VNA and spectrum analyzer. They're very sensitive to DC and can damage them. This is an inline attenuator and load, rated at 10 watts, 40 dB, 0 to 3 gigahertz, but actually when I measured it on the VNA, it's actually 41 dB. So this is why it's important to have VNA, right? This is one of two spectrum analyzers I've got. Oh, I just love these. This is the standard Ultra. There's an Ultra Plus as well, which I also treated myself to. But this one is perfectly good enough. Get yourself one of these and you'll be doing yourself a favor. And I also, here's my Ultra Plus. It's kind of got an extended frequency range and a few other bells and whistles and performance updates. I use one for signal injection and the other one for sniffing around after you inject a signal, because they can be they serve a dual purpose as a spectrum analyzer and an RF signal generator. Really versatile, and the two used together is a very powerful combination. So there's a plus, and above it there's a standard one. Standard one's good enough, but there are clones on the market, so I will leave links to my suppliers that I trust, so you can buy without apprehension. So that's it. There's my test tools. I'll leave links in the description for all of these. Now, a word about the supplied antenna. I commented before it is very long. This antenna supplied with the standard 950 and also the 920. If you referred to my video EB24 when I looked at the 920, I did an SWR test on this antenna. And have a look in EB24 around the 45-minute mark, and you'll see where I'm doing the test with my nano VNA. And I found that the resonant frequency of this antenna for the 70 centimeter band is well below 400. Actually, it's below 400 megahertz if I recall correctly. So it's peaking well below the 70 centimeter band. Change it for one of the shorter ones when you're Kwangshan or something else. At 2 meters, it's fine. Right, let's get started on the first test, which is the power test. So you see I've got my 41 dB attenuator and load there, connected via my DC block into the input of my Ultra. I'm using the standard one here rather than the Plus. So let me just show you what I'm going to do for every frequency. So number one, go to frequency and set the center frequency to the frequency of the test, 27 megahertz in this case. Then we always set the span to 500 kilohertz. Okay. Finally, you need to set the attenuation level. So that's the value of your attenuator load, which is minus 41 dB. Done, that's it. And we're going to repeat that effectively for every frequency under test. So now I'm just going to key up. I'll show you what I'm doing. So I've got on 27 megahertz, which you need to use the third key to key up. And the way I've got it set up. Alright, now I'm going to be whizzing through these tests, but don't worry, I'll summarize the results at the end, okay? So don't panic, I'll summarize it all for you at the end. Right, so let's get stuck into the first one, 27 megahertz. Fred in the shed's going to like this one, 34.9. Yeah, 34.9. And then into the 10 meter band at 28 megahertz. And looks like we got 34.4. And then let's go into the 6 meter band at 50 megahertz. Oh dear, 8.8. Yeah, 8. No one's at home. It's just, no, it's refusing. I'm not transmitting on 6 meters, it says. Right, on to 2 meters at 144 megahertz. 39.1. Whoa, almost 40 dB, almost 10 watts. Nice. But then what do you expect? Then into 1.25 meters at 222 megahertz. About, what do you reckon? About 23-ish. Give it a yeah, let's call that 23 dBm. And then on to the all-important 70 centimeters at 430 megahertz. So what's that? It's about 37.4 dBm. That must be about 5 watts, just over 5 watts. Finally, a bit of dark PMR. At 446, so we're getting about 36.3. Okay, on to the next set of tests, harmonics. So let's assume that you wanted to do 28 megahertz harmonic test. So the first thing you do is you go in and use a measurement function, and then you select to measure harmonics, and then you put in the fundamental frequency, 28 megahertz in this case. And then you set the span, which is also the same fundamental frequency, and that's it. Then you need to put in the level of your attenuation. So remember, we've got 41 dB, minus 41. Now you need to do this for every frequency. That's it. Right, first up, let's do the CB band. Everybody's favorite band, it would seem. Now you need to wait for it to settle. Basically you wait for the fundamental, you see the number 1 on the left there, to reach the power output that we measured earlier. Then you know it's kind of stable. And then you measure the second harmonic, right? So we get about what, 41.5, yeah. Okay, then on into 10 meters at 28 megahertz. Then we're getting about 41. Yeah, 41. And then into 6 meters at 50 megahertz. Now this is the one that didn't even get out of bed for this test. 50 megahertz, 6 meters, not happening. I'm not even going to bother. Okay, then on into 2 meters at 144 megahertz. What a superstar. Can't even see a harmonics. Down in the 60 dB noise down there. Can't see anything. Fantastic. Then on into 1.25 meters at 222 megahertz. I reckon that's about minus 54 dB. That's a very good result. Then up into 70 centimeters at 430 megahertz. What do you think? We've got 50.2, 50. I'm gonna take that as 50, and then A bit of dark PMR again. I'm going to take that at 50.2 dBc. Now, before we go on to the third test, which is sensitivity, let's take stock of what we looked at the moment. Otherwise, it'll all be a bit much. So I've listed out here the power output there. You can see in dBm. And for your convenience, I converted it into watts. That's a lot more meaningful for a lot of people, I guess. And I've also listed down the second harmonic. You notice at 6 meters, I didn't even bother to convert it to watts or even put down the second harmonic in dBc because it's just negligible, right? It's just non-existent. Bit hard to see in a table, so let's have a look in a chart. Okay, this is easier to understand. So down in 11 meters CB, Fred in the shed's going to be happy. We've got a reasonable bit of output there, and it's within legal limits for most countries. And also a respectable output at 10 meters as well, not much under the 11 meters, so perfectly usable for 11 and 10 meters. 6 meters, well, it's just not got out of bed, is it? Forget it. 2 meter band. No surprises here. I mean, virtually all these handhelds excel at the 2 meter band because you think of their evolution, they've all evolved from 2 meter and 70 centimeter transceivers, right? So good performance there, over 8 watts. 1.25 meters, not really useful. You just got a few milliwatts there. 70 centimeters, quite typical for radio in this class, around 5.5 watts. And PMR, not bad either, just a little bit under the 70 centimeters. Now, of course, none of this really matters if the emissions are bad, right? So let's have a look at how it's doing on an emissions chart. Oh my God, I never thought I would see the day. I can't quite believe how this radio performs on emissions. You see that red dotted line? That's a minus 40 dBc. Which is generally regarded as the threshold for the maximum level of emissions you can have for a radio to be legal in a particular band or frequency. And as you can see here, it surpasses that line in every single usable band. I never thought I would see that, quite honestly, a radio at this price point. And it just goes to show that finally, these Chinese budget radio manufacturers have listened to us and produced a radio which we can use without fear of breaking the law. Seriously, I take my hats off to Radtel on this one. And this is a very important moment, right? You might think I'm over exaggerating, but this is a really important moment because it'd be very difficult for anybody else now to compete with this without at least meeting this standard. So a new standard has truly been set. Thank you, Radtel. 非常感谢 Radtel. Now, to put these results in perspective, let's compare it to the RT-880 that I did a similar test on in video EB027. So if you haven't seen that, you might want to take a look at that as well. So I put them both on the table. You can freeze and take a screenshot if you want to look at that in more detail. But let's go over to a chart and have a look. So in blue, we've got the RT-880, and then in orange, the 950 Pro. And if you have a look, the power outputs are somewhat similar, right? There's not a lot to really distinguish them by. But where these two really diverge is when comparing the emissions. Let's go over to the emissions chart and take a look. So you can see here, whilst the RT-950 Pro has a walk in the park for exceeding the minus 40 dBc emissions limit, the RT-880 really struggles in every single band except the 2 meter band. So of course, it's not just this makes a good radio, right? It's also about the software, the support, how many bugs have you got, how easy is it to program, is it supported by chirp, and so on and so forth. But getting the hardware right is a key foundation in a good radio. If your hardware is producing emissions all over the place, it doesn't matter how good your functionality is or your software. basically you've still got a dirty radio. Now on to the third test, the sensitivity tests. Well, it's not really sensitivity in the real sense. To do that properly, you need to do something called a signal to noise distortion ratio test, or a SINAD. And I simply don't have the equipment to do that. So I'm really going to be doing a test which I would call the usable RX threshold test, which is where, sorry to be so primitive, I'm just going to connect it to an RF signal generator and slowly increase the level of RF signal from an inaudible level to the point where you can reasonably hear the audio through the noise. So yes, it's going to be subjective, but I think it's good enough to give you some idea about how sensitive this radio is. And to assist with that, I'm going to do a comparison between the RT-950 Pro and the RT-880 again, simply because it's well established and generally regarded as a good performer. So let's use that as a benchmark in the budget radio category. And if anybody's feeling generous and they want to donate some better RF test equipment to the channel, it would definitely find a good home here. Right, without further ado, let's get on with the test. I'm using my Ultra Plus as an RF signal generator through a 40 dB attenuator, DC block, and then into the radio. So I've got 800 Hertz tone, because I think it sounds better than 1 kilohertz, 80% AM modulation, and the level's currently set to -131 dBm. So I can't hear any carrier. So let's increase by 10 dB. Now you can hear it, so now I'm going to back it off by 1 dB steps. Okay, increase it. Okay, so I'm going to settle on that as a usable RX threshold, because I can hear a signal. I know it's subjective, but this is going to be my test method. If you've got any better ideas on how to do this, do share with me in the comments, given the test equipment that I've got. Right, so that was at 1 megahertz in the AM or medium wave band. Let's now try the long wave band. So I'm going to try it at 200 kilohertz. Let me know if you can hear something. Ah, here we are, 117. 117 I'm going to go. Now HF 10 megahertz. I'm going to go about 123, minus 123 dBm. Now 27 megahertz. I'm going to go about 122. Then FM. I'm going to set the deviation to 2.5 kilohertz. Okay, now at 50 megahertz, 6 meter band, I'm going to go over 105. Airband back to AM, 120 megahertz. I'm going to go over 125. 2 meters, 144 megahertz. I'm going to go over 129 or 128. 1.25 meter band, minus 180 dBm. 70 centimeter, 126. And finally, PMR, I'll say 127. Now let's do the same thing with the 950 Pro. Let's start off with long wave at 200 kilohertz. Increasing it by 10 dB, 119. Oh, 109. That's not so good. 99. It's something wrong here. Just check. AGC is, set it to 0 attenuation. Try again. Oh dear. Have I got anything wrong? Set AGC back on again. Oh my, it's deaf. It's deaf on long wave. Let's try 1 megahertz AM band. Got to change the radio frequency. Let's go into medium wave or AM band. Okay. 1 kilohertz. Sorry, 1 megahertz. Okay, we're at minus 140. Let's go up in 10 dB steps. Oh no. Guys, this is not good. Well, so far, unfortunately, I have to report it's completely deaf on long wave and medium wave at AM. Oh, things were going so well. Okay, let's try HF. Okay, I'm going to try at 10 megahertz. Okay, I'm going to take that at 125. Let's go on to 11 meters CB, AM of course, 127. 6 meters, 50 megahertz. Not so sensitive there. Okay, 111. And airband back to AM. I'm going to take that as a minus 118. 2 meters, 144. I'm going to take that as 125. 1.25 meters. I'm going to take that as 123. 70 centimeters. I'm going to take that 126. Now I lost the video footage for PMR, but that was also minus 126 dBm. Now I also will be interested to try HF on a dedicated HF receiver, see how it compared. So let's do 10 megahertz. This is XHData D808, so that's about minus 128. Also 27 megahertz, the same result. Then airband, 120 megahertz. We're getting about minus 122. Now I'm going to do a comparative test for FM broadcast.
Come up with their own plan for
you hear a bit of static on the 880.
They drew up a plan several months ago now, but I think as long as it just remained an Arab plan.
But you hear the 950 is very clean, so I'd say it has the edge.
States would be able to kind of dismiss it, to push it to one side.
And there you go. I don't know about you, but I think the 950 wins on audio quality as well. What do you think? All right, so I think we're going to finish up now. Let's have a look at the results in a table. Well, I'm glad we tested long wave and medium wave at AM. Wow, what a surprise, and not a nice one. Yeah, so completely deaf. The 950 is completely deaf on long wave and medium wave. Either I've got a dud, or well, I hope they're not all like that. Let me know in the comments. If you've got any problems receiving long wave, medium wave or AM, let me know. Now I'm leaning towards thinking this is a software problem, because if you look at this block diagram of the SI4732, you see it just has a single AM input which is shared with AM long wave and HF. So it works well with shortwave. So maybe this is easily fixed with a software update. Radtel, please take a look at this. This doesn't bother me that much actually, because I don't use AM or long wave, but I can imagine for some of you, especially in the US, you know, this might be more of a concern. So once again, let's have a look at this information in a chart. It's kind of easier to understand. So in the blue, we've got the Radtel 880, and in orange, the 950, and the black is the dedicated HF receiver, the XHData D808. So with the exception of long wave and medium wave at AM, you can see that the 880 and 950 are quite comparable on most of the bands, except 6 meters, where the 950 does much better than the 880. It also does better at 1.25 meters as well. You can see that the dedicated HF receiver is obviously better on the HF bands, but interestingly, the 880 excels on airband, with the 950 coming in third. So that's interesting. Well, I'm going to wrap up this video now. Thank you very much for joining me on what I thought was a really interesting set of tests. And if this video was useful or helpful to you, or even just interesting, please do remember to support the channel by giving me a like and subscribing. It really does help me. Now, if you're interested in getting one of these radios, be sure to check out the description. I've got a 5% off discount code for you. And I'll also leave links for all the other equipment that I've used in this video. So once again, thank you for joining me. And until next time, take care of yourselves and 73.